What if I told you that tonight, when you look up at the night sky, you are looking at more stars than there are grains of sand on every beach on planet Earth? Trillions upon trillions of them! And what if I told you that we now know that most of those stars have planets of their own? With all of that cosmic real estate out there, it leads to the biggest, most profound question we have ever asked: are we alone? Today, we are going on a journey to the heart of that question. We're not talking about UFOs or conspiracy theories. We are talking about the real science, the mind-bending paradoxes, and the thrilling search for extraterrestrial life. This is the story of our hunt for aliens. For most of human history, the idea of aliens was pure philosophy or science fiction. But in the last few decades, that has completely changed. The question is no longer if life could exist elsewhere, but where we should be looking for it. The science begins with some simple, staggering math. Think of it as a cosmic recipe for life. First, you start with the number of stars in our galaxy alone, about 200 billion. Then, you estimate what fraction of those stars have planets. We used to guess, but now, thanks to telescopes like Kepler, we know the answer is, almost all of them. Then, you ask how many of those planets might be in the Goldilocks zone, not too hot, not too cold, but just right for liquid water to exist. The numbers here are still huge, potentially billions of planets in our galaxy alone. This chain of reasoning is famously known as the Drake equation. It's a way to organize our ignorance, a framework for estimating the odds. And no matter how conservatively you run the numbers, it spits out an answer that is hard to ignore: life should be common in the universe. Our galaxy should be teeming with it. And this leads us to one of the most chilling and profound paradoxes in all of science. It's called the Fermi paradox. The paradox is simple: if the math says the galaxy should be full of life, and if even a fraction of that life developed advanced technology millions of years before we did, then, where is everybody? Think about it. The universe is incredibly old. If a civilization started just a few million years before us, a cosmic blink of an eye, they should have been able to explore or at least send signals across the entire galaxy by now. The galaxy should be noisy with their radio signals, their probes, their activity. But when we point our radio telescopes to the sky, all we hear is silence. A vast, empty, cosmic silence. It's like walking into a city with a billion houses, and finding every single one of them dark and quiet. This contradiction, this great silence, is the mystery that keeps astronomers up at night. So how are we trying to solve this mystery? This is where the modern search for aliens gets really exciting. We changed our strategy. We're not just listening for radio signals from little green men anymore. We're hunting for the fundamental building blocks and byproducts of life itself. First, we are becoming cosmic detectives. With incredibly powerful tools like the James Webb Space Telescope, we can now look at the atmosphere of planets orbiting other stars. We can analyze the light that passes through their air to look for biosignatures. Think of it like seeing the exhaust from a car. You don't have to see the car to know an engine is running. In the same way, if we find an atmosphere that is full of gases like oxygen and methane in a combination that can only be produced by living organisms, we found our smoking gun. We found evidence of life, even if it's just microbes. Second, we've had to completely redefine what life can look like by studying it here on Earth. We have discovered creatures called extremophiles that thrive in places we once thought were impossible for life. There are bacteria that live in boiling hot springs, microbes that survive in solid Antarctic ice, and organisms that eat sulfur next to volcanic vents at the bottom of the ocean, in total darkness and under crushing pressure. These extremophiles are like a cheat sheet for finding aliens. They teach us that life isn't fragile. Life is tough. It can exist in conditions we can barely imagine. This means that maybe we don't need to find a perfect Earth 2.0. Maybe life is thriving right now in an icy moon of Jupiter, or in the methane lakes of Titan. So where does that leave us in this grand search? We are living in the first moment in human history where we have the actual tools to find an answer. The question of are we alone? has moved from the realm of philosophy into the realm of testable science. The great silence of the Fermi paradox is profound. Maybe life is incredibly rare. Maybe advanced civilizations are even rarer, or maybe they don't last long. Or maybe, just maybe, we just haven't been listening in the right way, for the right thing. But the silence doesn't have to be a sign that we are alone. It can be a motivation. It is the mystery that fuels our curiosity, that pushes us to build bigger telescopes, to send probes to distant moons, and to keep looking up at that vast, beautiful, and silent sky, in wonder. Because finding even the simplest microbe on another world would be the single most profound discovery in human history. It would be the moment we finally learn that we are not alone, and that the story of life is far grander than we ever dared to imagine.